this organism does that. Flashcards, if that works for you, it's a great way to do this. Name an organism on one side, other side, maybe key points. Or some people do concept maps, which is what some of these handouts are going to do. Have a center organism, draw lines out to other circles, and put traits in circles around the center organism. That's a concept map. Study groups help. Jackie Caples, wonderful. Yes, you know that. Helps out with directed studies. Now, I'm going to continue. I'm not trying to make it dry. I'm going to try to make it well,
Ouch.
not ouch. Trying to make it interesting. You okay?
Yeah.
Okay, I just hear the first question in here. When I get a chance, I'm going to show you pictures and things like that, but right now I need to cover the material. I tend to do my work on the front end, so it leaves more time for more entertaining things a little bit later. We stopped last time with this handout on Bacillus and Clostridium. Bacillus and Clostridium. If you don't like the handout, which I understand is going to be revised, the same information is in your focus notes, just in text format. Every bit of information here is written out in text format in your focus notes. You have to have two sources of the exact same information. Yes? Oh, who needs a handout? Who needs a handout? Okay, that's okay. All right. Handout, this is the Bacillus and the Clostridium. These are the ones right at the top. Anybody else? Everyone else okay? We covered Bacillus, know the species. I broke it down into antibiotics, agricultural, pathogen. This is what I'm talking about, concept map. You do circles with lines to another circle, and you have related information. The ones that are antibiotics are Bacillus polymyxin, which you already know about, and Bacillus right here, lithiformis. What's that topical triple antibiotic that you put on cuts? Neosporin. Well, it's also other names. It usually has a formulation of bacitracin, polymyxin, and neosporin. They can change it up a little bit, but often that's the three antibiotics. Here's two of them. Right here. You don't take them internally because they will destroy your kidneys. There, I did have one person that said he treats all the sores in his mouth with the triple antibiotic cream. Now, granted, probably not enough is getting in, but I would not do that. I would not do that. So, hopefully people will be okay. Down here, your Bt toxin, Bacillus thuringiensis, that's to kill insects that eat your crops or your flowers. The pathogen down here, Bacillus and thracis, is anthrax. Cutaneous, less likely to kill you than inhalation. The two spore formers are Bacillus and Clostridium. We already did a Clostridium, we did that in lab, we'll do it again. Veillonella, this little fellow over here, V-E-I-L, like veil, and then L-E-N-I-A. That's also in the focus notes, written out and typed out. All I show about that is to be part of your dental plaque. It's a gram-positive cocci. It's an anaerobe, so don't think anaerobes can't grow in your mouth. All they have to do is what I said about biofilms. The roads at the top, facultative anaerobes throughout. What's going to be deeper in the biofilm? Or in a pocket in your gum, maybe. Anaerobe. They'll still get you. Don't think it won't happen. The one I didn't get to, which is where we're starting with new material, the mycoplasmas. Sorry about that. I am now going to have to tell you that everything I told you before is wrong. Because I have to teach you all bacteria have peptidoglycan. That's one of the definitive points of being a bacterium and the cell wall. Mycoplasmas are bacteria. They have no peptidoglycan. They have no cell wall. There's just this one little exception. Well, there are others too, but this is the one that's important. Mycoplasmas are bacteria. They have no cell wall, no peptidoglycan. They do have cell membrane, and they have some sterols, S-T-E-R-O-L-S, to help make their cell membrane a little bit stronger. Think of that something similar to like cholesterol, okay? To help make our cell membrane feel better, or worse. Now, as soon as I say no cell wall, and I did say osmotic pressure, what did I teach you about bacteria if their cell wall is damaged? Bacteria naturally have a higher solute concentration inside. Water flows in. The cell membrane expands up like a balloon up to the rigid cell wall like an exoskeleton, stops. There is no cell wall. So water keeps flowing in, you would think they would what? Blow up and break. So they have to live in specialized environments. Isotonic environment or situation means the number of solute particles outside and inside the cell are about the same. Isotonic. So water's going to flow up like an equilibrium, in and out about the same rate. They have to live in an isotonic environment or they blow up, they lyse. And you, that's your cell membrane. They like to live in cell membranes because there are other little factors and nutrients and things dissolved in there. And they can survive, including the mucus of your lungs. One of the causes of pneumonia can be mycoplasma. Can also be streptococcus pneumoniae. Can also be Klebsiella pneumoniae. Get the idea? More than one organism can cause pneumonia. More than one organism can cause diarrhea. More than one organism can cause gangrene. So don't think it's one. It's one. Other thing about this right here, they're the smallest free living cell that we know of. That doesn't have to be a parasite or something else. Smallest free living cell we know of. You go home and you take an egg and you break it and throw it into your frying pan and that's one cell. What does it look like? The yolk is up and the white, which becomes the white, goes flatter around. That's what they look like when they fly. As soon as you see that on a plate, a colony that looks like an egg was dropped with a higher center and a halo flatter around, there's a possibility it's a mycoplasma. Now back to no cell wall, no peptide glycan. So already we know it relates to osmotic pressure. It relates to where they can and cannot live. It also relates to their shape. What gives a bacterium its shape? The cell wall. The cell wall decides the shape. Well, they don't have a cell wall. So they are pleomorphic. What does that mean? Pleo means many. Morph or morphic means shape. They can have many shapes. They take different shapes as the bacterial cell does, not the colony. The colony has a Friday. Everybody okay? So very unique, sort of, what? Pleomorphic. P-L-E-O, pleo. Morphic, M-O-R-P-H-I-C. If you know your ancient Greek mythology, Morpheus was an ancient Greek character. He could change his shape. So that's pretty much the mycoplasmas. Everybody okay with that? Now some of this, which is actually good right now, is going to overlap with what you need to know for the midterm, so you're really getting some of this knowledge more than once. So moving to the back, the staph and strep. Staphylococci, streptococci. Okay. Technically, they're low G to C base pair ratio groupings, but I'm going to ask you just to know Staphylococci species and streptococci species. Staph. Well, you already know this. Staphylococcus epidermidis, natural resident. Staph aureus can also be a natural resident. Who's the flesh eater that's subgroup of Staph aureus? MRSA. MRSA. So don't forget that. MRSA can eat you. If you go to that link on my site, you may not want to watch this because it's very graphic. There is going to useful links. You go to Professor Michael Cronin. It shows a young gentleman that comes in and they're having to clean out a place on his leg from a MRSA wound and what they do. You may not want to watch that. but if you're nurses, you might want to watch it too. And he goes, I thought I had a spider bite. Well, he did have a spider bite, but it also moved to being a MRSA infection. MRSA infection. You want to see that? Okay. Yes, toxins, they produce toxins. They are heat-stable toxins. That means if you cook it, what happens to the toxin? Heat-stable. Nothing. Toxin, unless you really heat it a lot for a long time, makes it through. Makes it through. Okay? It says enzymes. What's that enzyme? Just learned it in lab. Coagulates. Coagulates. Causes coagulation around it. You can help it help them hide. Help them hide. Different types of diseases. Yes, it can be pneumonia. Somebody just told me they were just knew a person that was diagnosed with a staph pneumonia. How's that? Pneumonia can be caused by different things. All right? Wound infection, we said, joints, that's a synovial fluid. Wound infection will grow through the fluid in your knee, in your wrist, in your elbow. Toxic shock syndrome. The old knowledge was the lady thought she had toxic shock syndrome, she had a mental problem. I found out, no, there is an organism causing the nausea, the fever, the sickness, everything else. Okay? And of course, it'd be in the vaginal area. Everybody okay with this? You know MRSA, right? You know who MRSA is. Going down to the strep, often now called what? Enterococcus. Yes, don't forget that when you get out there. Still have flesh eaters. They still have ones that can eat your flesh. Strep throat, of course that's fire in the throat. You have to get what to get well? Antibiotics. If you have strep throat with you or your family, throw away the what? Toothbrushes. I had a doctor even mention, I talk to everybody, throw away the toothpaste, especially if you have kids. Because kids are real bad for taking that toothpaste and cramming the top of it down onto their toothbrush. So there's still a chance there. Yes, you can get strep throat again, and again, and again. If you don't treat it, it can go to scarlet fever. So streptococcus. There are people that can be carriers of anything. That means they have the organism, doesn't make them sick, but if they shed it off to somebody around them, that person will get strep throat. Some people are carriers of strep throat. Some people are carriers of MRSA. Some people are carriers of other things. So don't forget that. Wound, where I said, it says, well, pneumonia, of course. Inner ear infection. Inner ear infections often happen, especially with children, right? One of the major ones would be your strep. It can get bad. I know of one case where a young child had a repeating ear infection. It ate away the bones in her ear. The amble, the stirrup, all those little bones that help you hear are actually eaten away. Last I heard, they were trying to put some sort of artificial surgery, put something in there to let her hear, but I don't know if it worked or not. Don't know if it worked or not. So, inner ear infection is one possible cause, not the only cause. One possible cause. While we're talking about inner ear infections, let me take something else I'm going to repeat to you later. Have you heard of swimmer's ear? Swimmer's ear is not usually strep. Swimmer's ear is usually pseudomonads, which I'm going to repeat to you later. That's a gram-negative rock. What do you usually use? You use those drops. The drops are actually usually a combination of vinegar and isopropyl alcohol. Vinegar to drop the pH. Isopropyl alcohol to make it evaporate. So inner ear infections can still have more than one cause. Still talking about inner ear infections, going back up to staph. I know another case. Child had this horrible infection when they tried to open it up. There's a little place that is inside the ear. Pus just flowed out. Okay? White, then you got to a hard pus. You know what white hard pus looks like? Trying to get that out. They gave that child mupirocin, which is an antibiotic. Mupirocin is for often MRSA. So that child actually may have had MRSA and inside the ear. The doctor said, throw away your ear, what the kids listen to all the time, earbuds. And he said, don't use them anymore. This kid was using earbuds jammed into their ear constantly. And what's going to happen if you try to treat that and the child puts earbuds back in their ear? It's going to keep getting infected. Yes, I know they want to hear, but no, be sure you stop the infection, you clean it up, and get rid of them. You can't really what? Clean them. What you going to do with them? Okay? A little bit on the food related. The stereomonocytogenase, I said this overlaps with lab. Dairy products can also be meat. Can grow in your fridge. That's cold temperatures. But if you eat it, it gets nice warmer temperatures and it grows better. Cross the placenta, keel to form fetus. Right? Can actually, it won't be growing in ice cream, but it can be an ice cream waiting for you to let it warm up. Waiting for you to let it warm up. Lactobacillus. Lactobacillus. Who's he? He's usually a good guy. He's not an acidophile. He's a neutrophile that ferments and produces acid. He will drop the acidic area of the vagina. He will actually stop his own growth, doesn't kill himself. Stops his own growth at a certain level. And if the pH starts rising, he grows again and drops the pH back down. The pH starts to rise, he grows again, produces more acid, drops the pH back down. What happens if you take a broad spectrum antibiotic? Kill him. What happens to the pH? Goes up. Who's always lurking around? Candida albicans and yeast infection occurs. And yeast infection. That makes sense. He can also be, if you think about this, a bad guy, lactobacillus that is. Where? In your mouth. If you don't brush them, he produces acids. Acids in your teeth are going to, you're going to get cavities. You get cavities. Does that make sense? I told you this is a lot of this one. Yes?
And also what causes like rush.
Candida albicans especially. Yes. That's true. That's absolutely true. Okay. Now go ahead to the next one. I'm sure you have it. This is technically your high GCC base pair ratio organisms. I'm starting with one that says Mycobacterium and Corynebacterium. Let me know if you get a handout, please. Mycobacterium and Corynebacterium. You know what handout? Oh, thank you, handout. Because I know there's so many people, some people may not have a chance to do that. Mycobacterium and Corynebacterium. Mycobacterium and Corynebacterium. Everybody okay?
No idea.
Okay, certainly. And another one. Corynebacterium, again, is going to overlap with lab. That is for the pathogen. Corynebacterium, bless you. Diphtheria, which is diphtheria. That would be cat or vaccination. People getting vaccinations. I hope you ever see it. Pseudomembrane in the back of the throat. Club-shaped. All Corynebacterium have that different arrangement of palisades. What does palisade mean? White picket fence, side by side. Chinese letters, and what's the other one? V's. But to have V's, they're actually doing a special type of division called snapping division. That means when the two cells try to separate, there's 1 to 2, and the two try to separate, little tiny hinge of the cell wall stays. And it causes what should have separated, instead of separating, to snap together. And that hinge is holding them together, a little bit of cell wall. Excuse me. They also have inclusion bodies of phosphate. Technically, that's called a metachromatic granule. If you see those, that's very indicative. Everything is phosphate. Phosphate for ATP. Phosphate for the backbone for the DNA. Phosphate to make the cell membranes with a phospholipid bilayer. And many other uses too. So that helps them out. Moving over to the mycobacterium. Did I ready for me to switch to next species? Mycobacterium. Think two diseases immediately. Mycobacterium leprae, Mycobacterium tuberculosis, that is leprosy and tuberculosis. TB, tuberculosis. Very unique organism. Have you ever waxed your car and then it rains? What is the water? Heats up. Does water pass through a waxy type of substance very well? No. These organisms, which is what they're named after, will actually put a compound called mycolic acid in their cell wall. Mycolic acid in their cell walls. It's a lipid. It's a wax-like structure compound. As soon as I say that, if somebody in front of you has TB and they cough and they spit on the ground and it stays there for a while and it sort of dries up to dust and the wind blows it up and breathe it in, mycobacterium and TB are still alive because they hold water in. Water can't get out through the waxy layer, right? So they're resistant to drying out. They can live quite a while. Next thing, so let's say they have mycolic acid, that's an extra trait, an extra ability, correct? Anytime an organism has an extra ability from the wild type, it has to siphon energy away from higher replication levels to push the energy away to make the mycolic acid. If it's using much of this energy to make the mycolic acid, what happens to its ability to reproduce quickly? Drops. Very slow replicator. Very slow replication rate. Because its energy is being drained off to make the mycolic acid. Both of these affect treatment. One, you have a waxy lipid layer in the cell wall. You've got to find a way to get the antibiotic through that. Other, slow replicator. When you do hit it with an antibiotic, it's only slowly affected, and maybe those over there aren't yet affected at all. So you have to treat it for what type of time period? A long time period to get rid of the mistakes. You have to treat for a very long time. Yes?
So is the replication rate slow, or is it just in growth is slow? Like, at once it's
For
formed, does it grow slowly, or does it just replicate?
For microbiology, growth is defined as numbers, replication. There is no talking about replication. That's sort of a twist of microbiology. Am I okay? So you have to treat a long period of time with isoniazid or some other type of antibiotics to get rid of TB. Yes, they're now resistant tuberculosis organisms to antibiotics because people do what? The treatment's a long time, they take it for a while and then stop. This is one of the worst infectors in the world, not in the United States, but in the world. Kills almost more people than almost any other infectious disease. But that's not good. Okay? Next point about it, field of history. Do you know what it used to be called a long time ago? Back, say, in the time of cowboys and gunfighters. Before it left. It used to be called consumption. TB is coughing, maybe some blood in the sputum. The person also loses weight. They called it consumption because they thought it was consuming a person. The person gets thinner and thinner and thinner. They used to actually have TB asylums. You're talking about just as recently as the 1940s, 1930s. Family members would be taken away from your family. They'd go live in these sanatoriums, but they weren't really for crazy people. They were for TB patients. And they'd stay there for a while. But it used to be very, very much a problem. Going back to the 1800s. Have you ever heard of a gunfighter that, of course, they moved out west because we have humidity. What do you have out west? Dry air. So TB patients moved out west because they could what? Breathe better. He moved out west. He was actually a dentist by his career. He fought at the OK Canal, OK Corral, you know? Doc Holliday. Doc Holliday had TB. They called it consumption in those days. how stupid is it to go up against a gunfighter that knows he's going to die anyway? That's not too smart. He already knew he was dying. Okay? So, a little bit of history with TV. Yes, there's resistance now. Yes, there are times when people have been quarantined because they won't take their complete medicine, and one nurse once told me she knew a patient was actually handcuffed to a bed in the hospital, and then they sequestered him in other ways so he completed his course of treatment. His course of treatment. Okay. Yes, you can catch it. Dust and things blowing up in the air. Some of the worst things in the world. I'll bring it in. Now, both leprosy and TB. Go ahead.
Why do they do the skin test to know if you have a tuberculosis?
Skin test has some twist to it. It only detects if you have TB or had TB or had vaccination for TB. All three would be the positive. And people that aren't from the United States, and I know a person that was a child that was like 4 years old in Argentina, other countries vaccinate for TB. So that population becomes positive out of the TB skin test all the time. So if it becomes positive, they send you to get the what? X-ray. If they find the little tubercles, which are actually little colonies in your lungs, you have active TB. They won't let you work in the medical profession until you are cured. They check because they don't feel TB treating patients. But it doesn't mean you have to have TB now. You could have had it in the past. You could have had a vaccination. You could have it now. Or be a carrier, yeah. Hopefully that's not the case. I had one student that said she was from the Caribbean. They send her to get x-rays every time. She says, I can prove I've had the vaccination here. They said, no, you're positive on the skin test. She's had x-ray after x-ray after x-ray. Did that answer your question? Okay. So that's the TB. Going back to acid fast. Acid fast, remember you did the Schaefer Fulton and Dorner? Acid fast is another type of stain with certain dogs. Only 2 organisms in the world with this stain procedure, and we'll do it in lab, will come out hot pink. Hot, glowing in your eyes, pink. Only TB, only leprosy. This is one of the few times you can run a stain on some bacteria and you immediately know it has to be one of 2 organisms. With one exception, that won't work because the other one is a plant pathogen. Plant pathogens can't infect us because we have the wrong receptors. Okay? How'd you know? You have a patient, you have a sample from your patient, and comes back acid fast. How do you know whether your patient has TB or leprosy? Where did the sample come from? Okay? Was there a lung involvement with coughing? And yes, TB can hit other organs. That would push it toward TB. Or the skin lesions? That would push it to leprosy. So that would help you. One of the few stains that can drop you immediately into what the person may have. Now, there are leper colonies where this would move on to leprosy. Not in the United States anymore, where they used to be. There are countries where they have a small area. They have a top, a back, a front, and that's it. People live in that little open box. They're not allowed in the village. The government gives them a little bit of a stipend. They're supposed to go out into the fields and grow their own crops, but really what supports them are any family members that are willing to come out and drop off food for them. So there is still social stigma occurring to people that have, in this case, leprosy. Change what? They did. They call it Hansen's disease to try to avoid letting people know it's leprosy. Pretty much everybody nowadays knows Hansen's disease is leprosy. But that's why we did it. Try to stop the social stigma. Exactly. On Molokai in Hawaii, if you ever get a chance to visit, used to be a leper colony. It's a beautiful area on the top of one of the plateaus and one of the mountains. Gorgeous view of the ocean. You'll see it's a historical tourist area now, but yes, there's still some lepers that live there. Used to, though, it wasn't choice. Used to, the lepers were forced to go there. Anybody that went in there was never allowed to walk out. Once you went in, you stayed in. There's a graveyard on the site because eventually people died. One medical doctor wanted to help. They told him the rules. He did. He went in. He helped the people about 10 or 20 years. Never left. Finally caught leprosy. And his great he died without it out. But he knew that. Excuse me for the fraud. He knew that when he went in. That's back in the 1800s. There, I think that. So mycobacterium, obviously hard to ground stain because that macaque acid causes a problem, but you don't use the ground stain for them, you use the acid basket. Does that make sense? Leprosy starts in the colder parts of your body, moves in, what? Extremities, cuts off the ability of the peripheral nerves to feel. What does that mean? It means if you stomp, you know how bad it hurts to stomp your toe? That hurts. What if you don't know it? Or what if you put your hand on one of those burners and you don't know the burner zone because it's one of the glass black ones or something? You can hold your hand there and you'll never know. Never know. Yeah. Let's have a little more compassion. That's all right. That's so sad. And of course, you know the blood armadillos. So, feel sorry for armadillos. Not only because of the river and highways, but because they grow leprosy in the footpaths. Okay, now, next. So move to the next one. Actinomycetes. On the back. The actinomycetes. This is such an interesting subject. And I'm going to show you some pictures, and we did a little movie today, but I want to cover as much as I can first. The movie is actually not something I already told you about, but it's a better movie than what I had before. I'm always hunting for something. These are in the dirt. Everywhere you go, these are in the dirt. They are filamentous, which is filamentous bacteria, but their filaments aren't those huge honking hyphae of a mold. They're like tiny little thin hair, like the thinnest hair you can imagine. They're in the dirt. The reason they're very important is this is the biggest producer of antibiotics as a type of life form that we have. They're a major source of antibiotics for us. We used to send people out to get dirt from every place in the world hunting for more species of Actinomycetes, hunting for new antibiotics. Let's think about antibiotics. The organism produces a chemical that inhibits the growth and or stops the growth of other organisms. Right? He's doing that because he's competing out there in the environment. He's not doing that to give us what? Antibiotics. He's not producing it for our benefit. Now, resistance, where does resistance come from? If he's producing an antibiotic that kills and inhibits growth, he has to do what to it? He's got to be resistant. So naturally, right there is a source of the beginning of resistance. Right there. Okay. Actinomycetes, the only difference here is there's no T. Capnaic means they like to grow in higher what? Carbon dioxide levels. Higher carbon dioxide levels. They can grow, of course, mucous membranes. What do you grow in the back of your throat? We like this. Higher CO2. Right? Now here's another thing I have to back off and tell you what I told you before is a little bit different. When pathogens make you sick, residents protect you. There is an organism called, see I have to teach you one layer at a time. You've got to understand this before I can teach you the next layer. There is a type of organism that can become an opportunistic pathogen. Opportunistic pathogen. What that means is it's naturally not going to cause what you normally would not cause you to get ill. But if the opportunity arises, it will eat you. Now let's think about what can happen. One, right organism, wrong place. E. coli or intestines protects. E. coli, because somebody didn't wash their hands when they made your hamburger, is going to give you food poisoning. And I mean, one person got projectile food poisoning from E. coli. So that's right organism moves to wrong place. Another one, which I'm going to get into later, you have naturally in your intestines anaerobic bacteroides, you'll hear these again, that don't hurt you, they're in your intestines, they're a major component of your feces, those organs themselves. Anaerobes. If you're in a car accident, if there's any perforation of your intestines, and they get into your abdominal area, opportunistic pathogen that can kill you. One of the worst abdominal infections you could have. What used to be the old rules, I hear about shot in the gut. That shot in the gut, you're going to die. Because what happened? Organs in the intestines were released into the bloodstream and into the abdomen. You ever seen the old John Wayne movie? I want to say El Dorado, but I'm not sure. It's one where he's riding by and a kid jumps up and shoots at him from behind a rock and he shoots him back. Kid says, commits suicide because it says, my dad told me if you ever get a gut shot, you're going to die. And John Wayne told the dad he should never talk to kid that. But anyway, that was the old traditional knowledge. Going back to this, opportunistic pathogen. The other time it can get you is any time your immune system is compromised or impaired. Compromised immune system, who would be your population you should think of immediately? HIV. What's another one? Young children. What's another one? Elderly. What's another one? Cancer patients. You hit them with chemo, you're harming their fastest growing cells. That includes the immune cells. So as soon as I say immune compromised, any organism that's a resident can become an opportunistic pathogen and attack. Okay? They're very young, no immune system, there isn't microflora yet. The elderly, part of their immune system is starting to degrade. The TC cells go first. We've got to teach you about later. HIV, immune compromised, and cancer patients. One more. Immunosuppressant drugs are given to people for what? Organ transplants. Organ transplants. That's the 5 populations. You should know them right off the mark. Okay, but getting back to where we were, Actinomyces raleae can be an opportunistic pathogen, is what that is saying. Normally doesn't cause you a problem. However, if he does go bad, or if you can't protect yourself, he can liquefy your organs. Just absolutely liquefy. Moving a little bit over here, nocardia, that's an environmental type of actinomyces. All these are in the dirt. Just say they're all in the dirt. This is the one that can give you a positive acid fast, but he's never infecting a person, ever. So you don't need to worry about that. Recalcitrant, which is actually down here, is what these compounds are. A recalcitrant compound or substance means hard to break down. Recalcitrant means hard to break down. Well, look at the list. Waxes, this means pollution such as waxes, oil products, detergents, pesticides, rubber. How long do tires spend? Forever. You can't burn them or what? Toxic fumes, very toxic. They often take them, grind them up, and put them as the flooring in what? Children's playgrounds. Some of these nocardia can actually break down, but it usually takes them some time. Of course, you need to get rid of all the other things too. Dropping down to the streptomyces. Everybody okay? Streptomyces. I'm going to go for environment first. There's that word. Degrade, recalcitrant again. R-E-C-A-L-C-I-T-R-E-N-T. This means substances. Cellulose. What is cellulose? You write it down. Okay? Comes from the cell walls of plants. Comes from the cell walls of plants. That actually is hard to break down. Remember we said the cow with the methanogens and other organisms in its fourth stomach, rumen, can only break down the cellulose from grass if it has bacteria to do that for you. Can't break it down. Ligand is just the woody part of the plants. Chitin. What's your chitin? The shell of your lobster. Crack your lobster. Also the shell of cockroaches, grasshoppers, and insects in many cases. That doesn't break down very fast, does it? Okay. Moving to health. Streptomyces can produce, what are these? Tetracycline streptomyces should be there too. Erythromycin and torticollis, they are. Does that make sense? Right about that? Don't worry, I'm going to give you a break with a nice movie in a minute, but I just want to keep rolling for a little bit longer. Going to the next one. That's it. This does that. This does this. This does that. This does this. But I'm going to make it more interesting when I get some more pictures. Does everybody have the alpha proteobacteria with pathogenic and industrial application? Pathogenic and industrial application, alpha proteobacteria. That's hard. I'm not reading it. The first one you see over here is the industrial application. Alpha plus the proteobacteria, industrial application in pharma. You don't have it, let me know, I'll have it. Okay. Now, these are no longer placed strictly into GC-based ratios. These are based on other things. What does this mean? First, proteobacteria is just, I don't know why they did that. They go as bacteria. Alpha proteobacteria, beta proteobacteria, delta proteobacteria, gamma, what are these in? The A bacteria, the B bacteria, the D bacteria, that's essentially all they've done. I am not going to ask you if these fall into alpha proteobacteria. It may change them in the future anyhow. I am going to ask you to know each organism and its relevant traits. Each organism and its relevant traits. Okay? Ready, Beth? Starting with the top, industrial application. Industrial application. Way back when, do you remember Louis Pasteur? He worked with, if you put yeast into grape juice, you get alcohol water. If you put bacteria into it, you get vinegar, acetic acid. Well, if you want to make vinegar, here they are. In industry, sometimes they want to make large quantities of vinegar. Vinegar is acetic acid. What's the name of the first organism? Acetobacter. The other one's gluconobacter. They actually use those. If you ever buy vinegar and use it for pickling or anything, probably where they get it from. Vinegar. Okay? Going down here to a unique one called Caulobacter. Caulobacter. Caulobacter has an extra type of structure, not a pili, not a fimbriae. It's called a proboscis. Okay? All you need to think of is the extra structure to help it do what? Attach. As soon as I say that, he's often found in water. Or doesn't he need to attach to something if water is always flowing around? It helps him attach. One thing, and I'll show you a picture of this next time, he's very unique for forming a rosette, which means if you think of a bacteria with a long flagella, take 20 of them around the outside of the cloth and have all the flagella pointing to the center. That's what the rosette is. I want you to picture of this. Environmental though. I want you to picture of this. I'm going to draw a photo. He's in your drinking water. He's in your bottled water. He's in your tap water. He's in your shower water. He's everywhere. This is a rosette. These things are, of course, modal, and they will briefly tie themselves together in a rosette. What this is called by the flagella. Eventually, they will all separate and go do what? Swim off by them. And there's more than this. There's a whole bunch of them. That's Caulobacter. We used to do an experiment where at the beginning of the semester, you take a glass slide, fill up a clean beaker halfway with water from your bottled water out of the drinking fountain, drop the glass slide halfway in, holding it up with a string, and let it sit for the entire semester. At the end of the semester, we pull the slide, look at it, and guess what's stuck to it? Caulobacter. Caulobacter. Now, let's make it a little bit more interesting to us than environmental. 2 applications for biotechnology. If these things can stick to substances in water, that means the glue that they have works in water. One thing they're thinking about is, relates to ships, which might seem a little bit esoteric. When a ship moves through the ocean, it always has organisms and barnacles attached to the hull. The more time passes, the thicker the rough layer of barnacles and rock forms. What happens to their fuel consumption? They don't have a smooth hull now. They have a thick layer of rough rock and more weight. Fuel consumption goes off. That's not economical. You usually have to pull the ships out, dry dock them, and with very caustic techniques and chemicals, blast that stuff off. One thought process that's not done yet is use the Caulobacter glue, paint the ship hull, put some sort of antibacterial chemical in the Caulobacter glue, or anti-marine chemical, to try to keep things from attaching. Not working yet. The other one is your mouth. Your mouth. Your mouth has a lot of saliva. Isn't that water? So if you want to have some sort of dental work, or maybe something for your teeth, or a cap, or something that's constantly in there, they might be thinking about using some of the Caulobacter glue that can work in water. Still working on that. You ready with that? Okay, moving over here, environmental steel, back to our nitrogen-fixing bacteria. We've heard that before. Nitrogen-fixing bacteria. What is nitrogen fixation? 80% of the air we breathe is into gas. Bacteria, and only bacteria and cyanobacteria, take the nitrogen, link them to that first hydrogen, give you ammonium or ammonia ion. And later down the line, which is not nitrogen fixation, but just more, you get amino acids, you get proteins. If we don't have nitrogen fixation, ultimately we have no proteins. Okay. You ever walk through the seagrass? You didn't have a chance to do that at the ocean? The grass that lives in the ocean and the tide comes in and out and the waves of the water. Sometimes down in seagrass are azosperillum. When I say squirrel, you know the shape. Big, lazy. Yes. They're free-living nitrogen fixers, which means they just put fixed nitrogen down into the sediments of the estuary, and they help the seagrass grow. Free-living nitrogen fixers are also out here in the grass and out in farm fields. They give fixed nitrogen to the plants so the plants grow better. A step more involved are the ones that are with the lagoons that are symbionts. That's rhizobium. Rhizobium lives in little teeny nodules in the roots of beans, peas, clover, those type of plants. They live in the nodule. The plant does photosynthesis, gives them sugars. They fix nitrogen that gets into the soil and give the plant fixed nitrogen. If a farmer keeps draining the soil with a crop year after year after year, what eventually happens to his crops? They don't grow. You can spend more money and also pollute the environment with all the fertilizers and some toxic things to go with it. Or you can plant soybeans, beans, legumes, maybe some clover, which have the rhizobium that live in the little root nodules in the roots of the plant. The bacteria in the roots of those plants will put nitrogen back into the soil. Farmers do that. They used to do that. Work the fields for a while, drain them, then plant soybeans, or plant clover, or plant sweet peas. And some will even plow the plants back underneath the earth. But the whole idea is to put nitrogen back into the soil so you can keep getting more crops, getting more plants. Does that make sense? Okay. Moving over here to agrobacterium. Have you ever walked through a park and you see a tree or a tree branch that's got this big swell on the branch or on the side of the trunk? That's like a benign cancer. Technically it's called a gall, G-A-L-L. What it is agrobacterium have gotten into the tree or into the branch. They have a plasmid. Here we go. See, the knowledge keeps starting from here on, and even before, our knowledge keeps coming back at you. They have a plasmid called the TI plasmid. They go into this area of the tree, and the plasmid causes the plant to overproduce plant growth hormone. So what that means in that area The plant cells replicate what? Faster, more, and you get the gall, the ball. Doesn't hurt the plant, it's not gonna die. Just gives this organism a place to live where he's protected, that's a little bit special for him. Now, they're thinking about using this for biotechnology. The TI plasmid affects plant cells, right? So the thing about using it to help do different types of genetic engineering with what type of cells? Plant cells. Does that make sense? Moving over here to our pathogenic. I'll often try to break it down into pathogenic, environmental, or maybe industrial. Okay? Rickettsia. Rickettsia is typhus and Rocky Mountain spotted fever. Rickettsia is typhus, Rocky Mountain spotted fever. He is an obligate intracellular parasite, like parasite. Can only replicate where? Inside a host cell. Typhus isn't so much here, but I'll give you a heads up. In other parts of the world, there is a vector called lice. And the lice in other parts of the world often carry from one person to another. That's what a vector does, carries from one point to another, either a disease or previously I talked about DNA, but in this case disease. Carries rickettsia. So if the lice can carry rickettsia, what is it carrying from person to person? Typhus. What is increasing in our elementary school levels? And it's very high in there. Headlights. They are not at this time, the rickettsia are not in the lice in the United States. Does that mean they never will be? Hopefully it won't happen. Hopefully it won't happen. Other one is Rocky Mountain spotted fever. Yes, spots. I said Lyme disease has the vector, one has to bite you. Irritate. Rocky Mountain spotted fever is not necessarily irritate, but a tick has to bite you. And yes, it's spots. One student told me several years ago that a friend of her dad's went camping out west. Very physically fit gentleman. And if you ever want to tell me tales, I'd love to hear about it. Never use the person's name. Okay? Got spots on his foot. It was a pretty serious case. They had to cut his foot off at the ankle. Right? They thought they had contained it. Spots showed up on the calf of his leg. They had to cut his leg off up to the knee. Spots showed up on the thigh. They cut the leg off now all the way up to the torso, and yes, at that point in time, they stopped and contained it. But it's very real. Rocky Mountain spotted fever. Yes?
Is it like raised spots, like chicken pox, or is it like under the skin spots?
I don't think this is raised chicken okay, but it's still quite good spots.
How is it not in the blood system, like not in the bloodstream, or it's traveling? Is it only on the
This must have been traveling through the dermal tissues. If it hit the bloodstream, the invitation would have gone through. That's what she said was on it. She told me a real case that happened to her friend. No, that's not always how it happens. You can have Rocky Mountain spotted fever. This is my hard part. You can have Rocky Mountain spotted fever and treat it and not have the invitation. Their fever in this case is necessary. If you're going to the blood, the invitation will matter. Going to the blood, it's already.
How does it not get into the blood once they have it? Like, you know what I mean? Like,
You're saying they pushed it into the blood because of the invitation.
could they?
They could, but obviously they didn't in this case because it would have shown up elsewhere.
That's what it did. It kept going up.
Or it could move underground, not hit the bloodstream, but move to the tissues and dermal layers in your cell canal. Sometimes mercy does that too. Okay, it's pummel.
You know, like it from,
Tick bites. Pretty much you have that tick bite right now. Worse are mosquitoes. The worst are mosquitoes, the next worst are ticks. Unless, well, not yet. Not here yet. Hopefully never. I'm not trying to, well, I am trying to horrify you because you hope you remember. Okay. The other two, Brucella. Brucella. Coccobacillus, you've heard that before. Okay, you can't say what shape it is. Causes brucellosis. For us, not much of an issue. pretty mild. Some large animals, it means spontaneous abortion of the young. For cattle, it means spontaneous abortion of the young. A person has a ranch and they have this going through their cattle herd, guess what they lose? The whole next generation. That can break a person. That can break it. Now, what does endemic mean? E-N-D-E-M-I-C. Always present in our population. Colds are what? Endemic in our population. Somebody always has a cold. Endemic in the buffalo out west are brucella. They don't hurt the buffalo. They don't have a problem at all. Buffalo are now being raised because it's a nicer, more lean type of meat. And people eat buffalo steaks, not buffalo burgers. So if you have a buffalo ranch here and a cattle ranch right here, what can jump? Brucella. If it jumps, what happens to the cattle ranch? He loses his whole next generation. Sometimes this causes a bit of an argument out west. Because each person's trying to take care of their livelihood. Okay, that's brucella, that's rickettsia. We're going to flip to the back. Here you go, the B bacteria, the beta radiobacteria. I would really start, I know you have to do midterm now, but I start flashcarding these. This does this, this does that, this does this. Because when it comes to Unit 4, they're going to swim together, so they'll have a walk between the cells. Okay, we're going to do application to sewage first. Application to sewage. We have to treat our sewage when we're supposed to. You don't just want to release it into the environment. Two organisms, Zoglia aspergillus. Zoglia aspergillus. One helps with treatment in a sewage treatment plant, one causes problems. One of the things they sometimes do with clean water sewage treatment plant is they want the organic matter to form flocks, that means chunks. They can go through and strain out the chunks and go compost them, burn them, or whatever they want to do. But if you remove those chunks of organic matter from the water's a little bit cleaner. So Glia helps form the flocks if it's in the sewage water. So it helps. Sphaerotillus is like dissolved jellyfish. It keeps everything dissolved through the entire water column. If they try to collect up any flocks, nothing collects. So the water stays more loaded with organic matter, and it's not as easy to collect. If that makes sense. Okay. Moving down to environmental Phylobacillus. Phylobacillus, you may see this in a movie later. You go out west, sometimes they want to get a certain metal from low-grade ore. Low-grade ore means it has what, a very low level of metal in it. That gouge mountains, mountains of this ore piled up on this, a huge mountain. They'll spray water on it constantly. Water soaks in, helps the Phylobacillus grow, and of course the water drains out and they collect it in these huge retention ponds. So it happens that Phylobacillus is able to precipitate out of low-grade ore copper. So one of the ways we get copper, you can see the copper, the color copper in the water. Of course it's poisonous to the environment. They also, not with this one, but no, I can do that for uranium. Moving over here now to pathogenic. Neisseria, Neisseria. Ground negative, diplococci, active kidney disease. Can be non-pathogenic resident, can be gonorrhea. Gonorrhea often means pus coming out of the urethral area, especially from males. Okay? Can harm your eyes, can hit the cervix, the top of the cervix and heading up. Each person can become stiff. Okay, and of course it lives in membranes. Bordetella, this is a fussy one. Bordetella's full name is Bordetella pertussis. What is that? This isn't coughing that I have my midterm tomorrow, I'm tired, I've got this nagging cough that won't let me rest and won't let me sleep. This is break your ribs, urinate on yourself, crack your ribs, cough, or racking whooping, that's called whooping cough. Very dangerous for the very young. People are skipping the what vaccine? Because pertussis, DTaP, what's the P? Pertussis. Pertussis, they're skipping vaccination, also bad for the elderly. Now, yes, it's spread by air drops, that just goes without saying. Vaccinations are important, they really are, okay? So that's Bordetella. Any questions on that one? I'm going to move to one more and then we'll just see a movie. Actually, I'm going to look to see a movie and then I'll do the next one because I think there's time to be drilling to death. Okay, so a quick movie to help you have something a little bit to help wake you up if you're interested. What did I say? Corynebacterium is, what's corynebacterium? It is diphtheria. That's all right, you haven't had time to study, I know that, all right? Corynebacterium is diphtheria. So I'm going to give you I'm going to head for Balto, but this is a better representation. And you can find this yourself. So you wake it up.